We are going to start solving equations. So I want to look at this right here, and I want you to tell me, why is this problem a solve, and why has the other things that we've been doing been simplified? What's the difference? Yes?
Because it has an equal sign.
You're absolutely correct. It is because we have an equal sign. That is why we are solving, because we have an equal sign. Okay? So, the way that we solve these problems is we multiply everything by the LCD. So we did problems similar to this in our very first chapter. Our very, very first chapter, very, very early in the class, we did problems similar to this. What we are adding now is we are adding variables in the denominator. That's what's going to be different. We still solve these by multiplying everything by the LCD. We still solve, that's still how we solve it. Now, what I want you to get into the habit of first is factor the denominator. Okay, now in this particular problem, what that means is we're going to break the denominator down into primes. But getting into that habit of breaking things down and factoring makes the problem much simpler to solve. Okay, so we're going to start right there. So I have x minus 2 over 3. Can I break that 3 down anymore? No, it's a prime. I can't break it down. Okay, now I have x plus 1 over 4. What does 4 break down to? 2 and 2. Okay, and then I have 1 over 6. What does 6 break down to? Excellent. 2 times 3. Okay, now I am going to find my LCD. I'm going to find my LCD. So here, I'm going to go ahead and write down my 3. Okay, I don't have the 3 written down yet. I don't have it accounted for, so I'm going to write down a 3. In my next rational, I have a 2 and I have a 2. 2 times 2. I don't have either one of those accounted for, so I've got to write down 2 times 2. Okay, now my third term, or my third rational, I have a 2 right here. Do I already have a 2 accounted for? So I don't need to write it down again. Okay, what about here? I've got a 3. Do I already have a 3 accounted for? Yes, so I don't have to write it down again. Okay, so here we go. What I'm going to do now is I am going to multiply everything times this LCD that I found. So I have 3 times 2 over 1. I'm multiplying everything times that. So I have 3 times 2 over 1. And I am multiplying that times x minus 2 over 3. Do you see how I put that x minus 2 in parentheses? That's an important habit to get into. Anytime you see a binomial written in the top or the bottom of a rational expression, you want to put that binomial in parentheses. Okay? Then I am adding that to x plus 1 over 2 times 2. So I am going to multiply 3 times 2 times x plus 1 over 2 times 2. And again, I'm going to put that x plus 1 in parentheses. Okay, that is equal to 1 over 2 times 3. And that is 3 times 2 over 1. Okay, if it's in the top and it's in the bottom, I can simplify it out. Okay, oh, yes, question?
Why do you put the binomial in parentheses?
Because it is a factor and we have to keep it together. So right now, I am going to mark that 3 out. What do I have left right here with the 2 times 2? What value is that? 4. I've got to distribute that 4 to the x minus 2. That's why we put it in parentheses. Is because that binomial, the 4's got to be distributed to that binomial. Okay? And when we have it written in this form right here, this x minus 2 over 3, that is actually a grouping symbol. That fraction bar is a grouping symbol. And so to help us remember that that fraction bar is a grouping symbol, we put parentheses around it. Good question. Okay. I'm right here. This is where I'm at now. So I have 2 2's on the top and I have 2 2's on the bottom. Okay. So now I've got 3 times x plus 1. Okay. Then I've got 3 times 2 on the top, 2 times 3 on the bottom, so I'm left with 1 times 2. Now, do we know how to solve this? We do. Okay, we're going to distribute and we're going to solve. So I have 4 times x minus 2, that's 4x minus 8, plus 3x plus 3, I'm distributing that, equals 2. Okay, I'm going to combine like terms. I have 4x and 3x on the same side. 4x and 3x is 7x. Minus 8 and positive 3 gives me negative 5. Okay, I'm going to add 5 to both sides. When I add 5 to both sides, I'm left with 7x equals 7. So what is my x value if 7x equals 7? 1. Okay, because I divide both sides by 7. Okay, and I get x equals 1. Okay, so my answer to this right now is x equals 1. X equals 1. Okay, now I want you to look at this particular problem. Do I have any variables, an x, a y, an n, a k, any variable or any unknown in the denominator? No, I do not. When I look at this one, do I have a variable in the denominator? Yes. So I want you to grab your phones. I know everybody has their phone pretty close to them. And I want you to do 4 divided by 0 on your phone. What happens? Error. Error. You cannot divide by 0. Okay? We cannot have a 0 in the denominator. Okay? We cannot have a 0 in the denominator. So for this problem right here, I have 5 over n plus 1/2 equals 9 over n. So the question I ask myself, what value or values can n not be? Okay? Another way to ask that question, okay, whoops, let me write this. What value can n not be? That's better, right? What value can n not be? Okay, another way to ask that is, what values of n make the denominator 0? Okay, so the way that we figure that out is we take this denominator and we set it equal to 0. Okay? Now they will get more complex, but in this particular problem, what is it that n can't be? N can't be 0. Okay? Now, n can't be 0 here, and n can't be 0 here. Okay? Do I have n in this denominator? No, so I don't have to worry about that denominator because I don't have a variable in it. Okay? So we have to think about what values of n make the denominator 0, And if we get that as an answer, we have to throw those values out. We have to throw those values out. Okay? So we have to keep that and remember that as we are solving these problems. So here we go. I want to find my LCD now. So I'm going to find my LCD. Okay? I'm going to write down this denominator. So I have an n in my LCD. My second denominator is 2. Have I accounted for that 2 yet? No. So I'm going to do n times 2. My third denominator has an n in it. Is that okay? I mean, do I have an n already accounted for? Yes. So my LCD is going to be 2n. Excuse me. So I am multiplying everything times 2 times n. Yes?
Could you write it as n squared, or does it have to be 2n?
N squared is not the same thing as 2n. Okay? N squared means n times n. Okay? 2n means 2 times n. So they're two different things. So you do need to write it as 2n. Good question. Okay, so now I am going to multiply 2n, and that's going to be 2n over 1, times each one of my rationals, or my fractions. Okay, so I have 2n over 1 times 5 over n, plus 2n over 1 times 1/2 equals 9 over n times 2n over 1. Okay? And when we do this, we are able to get rid of all our denominators. That's why we multiply everything by your least common denominator, is because then we get rid of the denominators. So n and n cancel. I'm left with 2 times 5. Okay? A 2 and a 2 cancel, and I'm left with n times 1. An n and an n cancel, and I'm left with 9 times 2. So I have 10 plus n equals 18. I subtract 10 from both sides, and what's my value of n? 8. Okay? Does 8 make this denominator 0? No. We said the only value that n could not be was 0. We got n equals 8, so we're golden. Okay. Can I move to the next screen? 35 minus x over x equals 7 plus 3 over x. I'm going to go ahead and write this 7 over 1. First question. My first question. What makes this undefined? What value of x can x not be? 0. X can't be 0. Okay? So if I get x equals 0 in this particular problem, I have to throw it out. That's what I have to do. Okay? So now I'm going to focus on my LCD. My LCD. I have an x right here. So I'm going to write that down for my LCD. Here I've got a 1. Can I just write times 1? Do I have to write times 1? X and x times 1 are exactly the same thing. Here, do I already have an x accounted for? Do I have to write it down again? No. So I am going to multiply everything times x. Okay? So I have x over 1 times 35 minus x over x. And I'm going to put that binomial in parentheses. Then I have 7 over 1 times x over 1. Then I have plus 3x times x over 1. Okay, now I'm going to start canceling stuff out. So I have x and x. I'm left with 35 minus x. Okay, that equals 7 times x. Okay, then my last one, my x and my x cancel, and I have plus 3. Do I know how to solve this problem? Yes. First thing I'm going to do is I'm going to add 1x to both sides. I'm left with 35 equals 8x plus 3. Okay, I'm going to subtract 3 from both sides. I'm left with 32 equals 8x. I divide both sides by 8. What is my x value? 4. Is that okay to have x equals 4? Is it okay? It is. Okay. Okay. Can I go to the next screen? No? Okay. Perfect. Thank you. Okay, here we go. Now, students look at this one and they think, can't I cross multiply? Alicia, can I cross multiply with this one? The answer to that is yes. You can cross multiply. You are allowed to cross multiply when you have a fraction or a proportion set equal to another fraction or a proportion. So you are allowed to cross multiply in this. However, I want you to get into the habit of doing it with your least common denominator. But if you choose to cross multiply here, you're okay. You can certainly do that. So what we are going to do here, the first thing that we're going to do is we're going to find out what values can A not be. Okay? If I plug 0 in for A, if I plug 0 in for A, in 3 over A minus 2, what do I get in my denominator there? What do I get? Negative 2. So is 0 okay in this one? Yes. Okay. But what value for A makes my denominator 0? 2. So in this situation, A can't be 2. Because if I plug 2 in here, what do I get in the denominator? 2 minus 2. 0. Okay, so that's 3 over 0. Okay? So, in my second denominator right here, I've got A plus 1. A plus 1 can't equal 0. So what can A not be? Negative 1. Good job. Okay, so I am looking for, if one of my answers turns out to be A minus 1 or A equals 2, A equals negative 1 or A equals 2, I have to throw that out. If one of my answers turns out to be 2 or negative 1, it has to be thrown out because it makes my fraction undefined. So I'm going to be on the lookout for that. Now, my LCD, I've got to make sure that both denominators are accounted for. A minus 2 is a binomial. I can't break that up any. It's A minus 2. What's my other denominator? A plus 1. So I've got A minus 2 and A plus 1. Okay? So that's what I'm going to multiply everything by. I'm going to multiply both sides by a minus 2 times a plus 1 over 1. Okay? So I have a minus 2 times a plus 1 over 1 times 3 over a minus 2. And that is equal to 4 over a plus 1 times a minus 2, a plus 1 over 1. Okay? If it's in the top and it's in the bottom, I can cancel it. So I have a minus 2 times a minus 2. So I'm left with 3 times a plus 1. What am I going to have to do there? Good. Then I have a plus 1 and a plus 1 cancels. So I am left with 4 times a minus 2. Okay? 3a plus 3 equals 4a minus 8. I'm solving now. We know how to solve these. So I'm going to subtract 4a from both sides. I'm left with negative 1a plus 3 equals negative 8. I subtract 3 from both sides. Okay, so then I'm left with negative 1a equals negative 11. I divide by negative 1. What's my a value? Good. Is that 2 or negative 1? No. So am I okay with a equals 11? Yes, I'm okay. Okay. Now, for our next one, I want you to tell me my undefined values. Can I move off the screen? Okay. I want you to tell me my undefined values. What can A not be? Okay, or another way to think of that is, what values for A make this equation undefined? Okay? What can A not be, or what values for A make this equation undefined? Okay? So I am going to take, I don't have to worry about this one. Why do I not have to worry about 3? There's no variable. So I don't have to worry about that one. I only have to worry about the a minus 2 and the a minus 2. Okay, so what value of A makes this undefined? 2. Because if I put a minus 2 cannot be 0. So A cannot be 2. If A is 0 here, I'm fine. I have no issues if A is 0. If I plug that in, I get 0 over 0 minus 2. That's 0 over negative 2. Is 0 in the numerator okay? Yeah, that's just 0. Okay, it's 0 in the denominator that I can't have. Okay, so my values here are that A cannot be 2. My LCD, that's what I want to focus on now. My LCD, I have a minus 2. That's a binomial. Okay, have I accounted for this 3 yet? No, so that's going to be part of my LCD. Have I accounted for that a minus 2? Yes, so I'm good. So I'm going to multiply everything times 3 times a minus 2. That's what I'm multiplying by. 3 times a minus 2. And that's over 1. You can think about that as over 1. So I have 3 times a minus 2, and I would not multiply that yet because some of this is going to cancel out, times a over a minus 2 plus 3 times a minus 2 over 1 times 2 over 3 okay, equals 2 over a minus 2 times 3 times a minus 2. Okay? A minus 2 times a minus 2. So we are left with 3 times a. Okay? For my second one, my 3's cancel out. So I am left with 2 times a minus 2. I'm going to have to distribute that 2, so you got to be careful there. Okay, and then here my a minus 2 and my a minus 2 cancel, so I'm left with 2 times 3. Do you know how to solve that? Yes, we distribute the 2, and then we solve for a. So I have 3a plus 2a minus 4 equals 6. 3a plus 2a is 5a. Okay, I add 4 to both sides. I get 5a equals 10. I divide both sides by 5, and what do I get for my a value? 2. Is that okay? No, it's not okay. So what we have to do is we have to throw that out. We cannot have a is equal to 2, because if a is equal to 2, our fraction is undefined. So my final answer to this is no solution. Okay? If you wrote undefined, that would also be acceptable. Okay? No solution, undefined. You could also do the empty set. I typically don't see the empty set that often at this level, but you could write the empty set. Okay. Okay, can I go to the next one? Okay, I am going to give you 2 minutes to try this one. Okay, so you're going to find, first thing that you're going to find is your undefined values. Okay, what can x not be? Oh, goodness. Okay, that's the first thing. What can x not be? Okay, then you're going to find your LCD, and then you're going to solve. And I would encourage you not to cross multiply. Okay, you just want to get in the habit of working with those LCDs. Okay, you've got 2 minutes. Okay, the first thing that you are finding out is what can x not be? You should have done x plus 6 equals to 0. And so x cannot be what? What? Negative 6. And x plus 6 can't be 0. X can't be negative 6. X minus 5 can't be 0, so x can't be 5. So those are the values that we're looking for that we have to throw out. The second thing I wanted you to find was your LCD. What's your LCD? Excellent. X plus 6, x minus 5. So we are going to multiply all of this times x plus 6 and x minus 5. Okay? So we have x plus 6 times x minus 5 over 1. And we are multiplying that times 5 over x plus 6. Then I have 7 over x minus 5. And I am multiplying that times x plus 6 times x minus 5. Okay, and all of that is over 1. So in our first rational, my x plus 6 cancels out. What do I have to do with this 5? What am I going to have to do with it? I am going to have to distribute it. Okay, I'm going to do that in my next step, but I do have to distribute. X minus 5 and x minus 5 cancel. I'm left with 7 and x plus 6. Okay, what do I have to do? Distribute. 5 times x is 5x. 5 times negative 5 is negative 25. Okay, 7 times x is 7x. 7 times 6 is 42. Okay, 5x minus 25 equals 7x plus 42. First thing I'm going to do is I'm going to bring my 7x over. So I'm subtracting 7x from both sides. That gives me negative 2x minus 25 equals 42. I'm going to add 25 to both sides. I get negative 2x equals positive 67. Okay? My next step is to divide by negative 2. So x is 67 over negative 2. I always move my negative to the numerator. So negative 67 over 2. You might have written that as negative 67 over 2 like that, and that would have been fine also. Or you could have kept the negative in the denominator. Any of those is fine. Okay? We good? Okay. Let's do this one because we are running out of time. So I have x over 2x minus 8 plus 16 over x squared minus 16 equals 1 over 2. Okay. The first thing I want you to do is factor the denominator. We are going to factor the denominator first. We are factoring the denominator. Okay? So I have x over 2 times x minus 4. Okay? I factored out a GCF. Then I have 16 over x plus 4, x minus 4 equals 1 over 2. So I have factored the denominators. That's what I did first. The next thing I want you to do is I want you to find for me the undefined values. Okay? The undefined values. Undefined values. So here, I have x minus 4 in my denominator. So x minus 4 can't be 0. So what can x not be? 4. Okay, so one of my undefined values is that x cannot be 4. Okay? Now, here, I've already seen and done x minus 4. It can't be 0. So do I have to do that again? No. Here, can x plus 4 be 0? It can't be 0. So what can x not be? Negative 4. So x cannot be 4 and x cannot be negative 4. Now what I want you to find is my LCD. So now I'm looking for my LCD. Okay? So here I have a 2 and I have an x minus 4. So that is going to be part of my LCD. Okay? Here, I've already got the x minus 4 taken care of. Do I have the x plus 4 yet? No. So I've got to write x plus 4 as part of my LCD. Here, what do I have? A 2. Do I already have that accounted for? Yes. So I don't have to do it again. So now that I have my LCD, I am going to multiply all of this times my LCD. Okay, and my LCD is 2 times x minus 4 times x plus 4. And all of that is over 1. Okay. So I've got 2 times x minus 4 times x plus 4 over 1, and I am multiplying that times x over 2 times x minus 4. Okay, I'm going to do that again with my second term. 2 times x minus 4 times x plus 4 over 1 times 16 over x plus 4 times x minus 4. That equals 1/2 times 2, I'm going to have to erase over here, x minus 4, x plus 4. And all of that's over 1. Okay? Now, if it's on the top or the bottom, I can cancel it. So I have a 2 and I have an x minus 4. So I'm left with x times x plus 4. What do I have to do with that x? Distribute. Okay? My second one, I have x plus 4 and x minus 4 in the denominator. So I can get rid of both of those. I'm left with 2 times 16. My third fraction, I can cancel my 2's, and I'm left with x minus 4 times x plus 4. Okay, now it seems like we've got a whole bunch right there, but we were able to get rid of all the denominators. We were able to get rid of all the denominators, so we've got to stick to that. So now we're going to distribute and we're going to FOIL. X times x is x squared. X times 4 is 4x. 2 times 16 is 32. Okay, when I FOIL x minus 4 times x plus 4, I end up with x squared minus 16. Okay, so let me show you. X minus 4 times x plus 4. That's the difference of perfect squares. X times x is x squared. X times 4 is 4x. Minus 4 times x is minus 4x. Negative 4 times 4 is negative 16. Okay, so I have x squared minus 16. Now what I'm going to do is I am going to solve for x. When I subtract x squared from both sides, what happens? It cancels, which is very nice. Okay, so now what I am left with is 4x plus 32 equals negative 16. I subtract 32 from both sides. I'm left with 4x equals negative 48. And when I divide by 4, what do I get? Excellent. Does negative 12, is it included in my undefined values? No. So negative 12 is okay. Negative 12 is okay. Okay? These take some time. I am going to focus on adding and subtracting rational fractions at the help session, but I will also be doing